Okay, part E, right? This is arguably the hardest part of this question. It says at a point P, the ice skater is skating parallel to the y-axis for the first time. Find OP, so that's the length or the distance OP. Now, the first thing to think of, guys, is look, the skater's moving around. Well, he's probably moving around and just all over the place, like he's skating around the ice rink. And this whole thing models that this is the displacement, this is the velocity. So if he or she is moving around like this, when is the first time they're skating parallel to the y-axis? Well, the answer is, if you followed it, I started here and I went along here. The answer is there. It's this part here. It is tangent. It is tangent to the y-axis here, and that's what it means, parallel to the y-axis. Now this, in relation to our velocity and displacement vectors, what's going on? Well, it's when the rate of change of the x direction is 0, or when the velocity in the x direction is 0. Because think about it, this x dot or dx dt tells us the velocity of the ice skater in the horizontal direction. It's the horizontal velocity, and this guy tells us the vertical velocity. Well, if the skater is just skating straight up like this, or imagine you were just driving straight up like this, but let's stick with the skater. If you're skating straight up parallel to the y-axis, what happens is your velocity in the x direction is 0, because you're not moving left or right at all, you're just moving straight up. So what we're looking at, or the key to solving this problem, is we need to find the first place that the x dt equals 0, or x dot equals 0, and this is the reason why. Okay, let me get rid of this. So we need to say x dot or dx dt is equal to 0. That's the first mark. And just to write that down, then I need all this equals to 0. A e to the bt. I'm gonna leave a and b in there for a second, even though I have a and b here, but just to make it a bit easier for me, b cos t minus sine t equals 0. Now, if you remember, guys, have two things multiplied together equals 0. This and this are, the a is obviously 5, so that doesn't count. So either this is 0 or this is 0, but e to the bt can't be 0, because if you remember e to the, well, it'll be e to the negative 0.7 t. That can't be 0, because it would just be, there will be an asymptote at the x-axis, so that can't be 0. Sketch it if you don't believe me. So this has to be 0. So b cos t minus sine t has to equal 0. And b, now I'll sub it in, is minus 0.7 cos t minus sine t equals 0. Now you could rearrange this for tan and solve it that way. Because I have a calculator, there's actually no need to do that, even though the mark scheme, I think, does it that way. But let's just do it like this. I'm literally just going to sketch this function here. This minus 0.7 cos of t minus sine of t. Sorry, I can't put t. What am I doing? It has to be, I have to use x for the, when I'm drawing with my calculator. But just remember, guys, remember it's t. Don't get confused. I'm solving for t. Also, I need to change this to radians, guys. I nearly made that mistake. But anyway, the first point is going to be this one here. It's the first time that he's skating parallel. It's the first time that he's skating parallel to the y-axis. The first time that he's skating parallel to the y-axis is going to be this. It's the first time when this function equals 0. So whatever this is going to be here, let's find it as menu, analyze graph, 0. I have to do lower bound, upper bound, and there it is. 2.53. So I'm going to write here t is equal to 2.53. But that's not the question finished, guys. I need to find where is this. So where is he at 2.53? Well, I need to sub it in here. So xy is now equal to, I have a and I have b and I have t. So a bit like the last question, I'm just going to sub in these points. So I have 5 e to the bt, and t is 2.53, cos of 2.53. And down here I have 5e to the minus 0.7 times 2.53 sine of 2.53. And this is equal to, right, let's do these separately. So I have 5 times e to the negative 0.7 times 2.53. This times cos of 2.53. That's minus 0.696591 minus 0.6, what did I say? 696591, 696591, and let's do it for sine. So I'm just going to copy and paste this, guys. Copy, paste, and I'll change this to sine of 2.53. So it's 0.488514. 0.488514. So that is the displacement vector. So that means he's at this point, he's at minus 0.696591 and 0.488541. So we need to find the magnitude of this. So the magnitude, therefore, I'm going to say therefore OP, so this is like P, OP is equal to, it's just this, it's the square root of this squared plus this squared. It's the magnitude of a vector. So it's the square root of negative 0.696591 squared plus 0.488514 squared, and that equals finally the square root of, I'm going to do copy and paste again, copy and paste, copied and pasted the whole thing. Okay, it doesn't really matter. Squared plus 0.488514 squared gives me 0.850814. 0.850814. Three significant figures. 0.851. Okay, there we go. That is the length OP.